Hello, everyone, and welcome to this special Western Drought Media Briefing focusing on the Pacific Northwest and Missouri River Basin. My name is Veva Deheza, and I am the Executive Director of NOAA's National Integrated Drought Information System, or NIDIS. NIDIS was established by Congress in 2006 by public law and has been reauthorized twice with strong bipartisan support both in 2014 and 2019. We are an interagency program within the Climate Program Office, which is part of NOAA's Office of Oceanic and Atmospheric Research, also known as NOAA Research. NIDIS's mission is to develop and provide a national drought early warning system, to coordinate and integrate as practicable federal research in support of a drought early warning system, and finally, to build upon existing forecasting and assessment programs and partnerships. I would like to thank everyone who worked to put this briefing together, including our federal partners across NOAA's National Weather Service, the Office of Oceanic and Atmospheric Research, the U.S. Department of Agriculture, and our colleagues at the National Interagency Fire Center, as well as our academic partners and sector-specific representatives. Next slide, please. First, allow me to cover some important housekeeping items. At this briefing, participants will be muted, and the briefing is being recorded. The recording will be available on the NIDIS YouTube channel and linked from the Briefings event page found on drought.gov. Please check the chat box periodically throughout the briefing for links to some resources that will be mentioned throughout the briefing. We have 2 times on the agenda to take a few of your questions. For questions in today's webinar, we will use Slido. Next slide, please. If you are joining from the WebEx desktop app or web app, you can participate by using either the Apps or Slido button at the bottom right-hand corner of your WebEx window. Please include your name and affiliation in your question. We will get to as many questions as possible in the allotted time we have, and will provide contact information for follow-up if needed. Next slide. The 2026 Western Drought Media Briefings being held today will deliver timely and relevant drought and fire conditions, outlooks, as well as perspectives from decision makers on the ground who are responding to the significant impacts of this drought. The briefing will include a summary of past, current, and forecast drought conditions, including ENSO outlooks. We will also learn about potential and ongoing impacts from drought across communities and sectors. We hope this briefing will be useful in helping you to translate complex drought-related data into clear communications that resonate with communities across the West grappling with the impacts of this drought. Next slide. So at this point, I am pleased to introduce Ed Clark, who will help us kick off this briefing. Ed is the director of NOAA's National Water Center, and he's also the deputy director of the Weather Service's Office of Water Prediction. He oversees the advanced forecasting and national modeling driving our water intelligence for communities nationwide. Welcome, Ed.
Thanks, and thank you, Viva. So the mission of the National Water Center and the Office of Water Prediction, in which we reside, is to produce actionable water intelligence for all manners of applications, from floods to droughts and everything in between. And we do so by developing tools and techniques and models and information graphics, geospatial analyses that support the comprehensive understanding of our nation's water, both as a hazard and as a critical natural resource. We do so in partnership with NIDIS. And indeed, it was our partnership with NIDIS that, as the sparse precipitation across the West began to manifest itself in a really unusual snowpack, one that NIDIS forecasters and coordinators characterize as a snow drought. That characterization set the stage for the water supply forecast, some of the lowest that we have issued in the last 25 years by our river forecast centers, to really be conceptualized and put in perspective for what was now we see at the latter half of the summer and into the fall, a truly challenging water supply year. Our partnership with NIDIS doesn't just stop there. Indeed, we invest through our Cooperative Institute for Research and Operations in Hydrology in projects that support the advancement of water resources understanding. Things like better snow accumulation and ablation models, particularly for the West, and to characterize low flow in ways that are meaningful for both hydrologic as well as more broader drought-related applications. Our partnership is truly rich and deep, and yet there's another aspect of this partnership that all of you here from the media play in communicating and conveying the importance of water as a resource to our nation. This year in particular, the stories that are coming and that yet to come from the western half of this country are one that really shows the critical importance of the forecast that NOAA produces and the role that we can play in providing contextualization of water as a critical resource. So I thank you for your interest and your time to be here today to learn from our colleagues across NIDIS and the federal sector. Thank you very much, Veva. I'll turn it back to you.
Thank you so much, Ed, for providing your very important context for the briefing today. I'm going to now turn it over to my colleague, Jason Gerlich, who's going to introduce the first panel and discuss current conditions. So Jason, take it away.
Thank you, Veva. My name is Jason Gerlich, and I'm the Pacific Northwest and Missouri River Basin Drought Early Warning System Coordinator here at NIDIS. First panel in today's briefing will focus on drought conditions and forecasts in the seasonal fire outlook and will be constructed as follows. I will first discuss current drought conditions across the Pacific Northwest and the Missouri River Basin. Then I'll be followed by Brad Pugh from the Climate Prediction Service at NOAA's National Weather Service. Following Brad, we'll be joined by Andy Hoell from NOAA's Physical Sciences Laboratory to share the ENSO outlooks. And then Jim Wallman from the National Integrated Interagency Fire Center to provide the significant wildland fire potential outlooks. After these respective briefings, there'll be an opportunity for Q&A. And with that, let's dive into the conditions update. Next slide, please. Again, as I mentioned, I am the coordinator for the Missouri River Basin, as well as the Pacific Northwest Drought Early Warning System. As we progress through this conditions update, I'm going to start sort of in the longer term perspective. And then as the slides progress, we'll get to more of the real-time to current conditions to being able to look ahead to the next 7 days to see what our expectations are moving forward. Next slide, please. A lot has been said about this year's snow drought. So I'm not going to go too deep into those conditions that occurred across this winter and into the spring season. However, we can start to see through the slides that will progress into the current conditions the impacts of that snow drought, especially as it relates to some of the state declared drought emergencies that have been occurring across large portions of this region that we're discussing in today's briefing. From Montana, who's had a statewide drought emergency since 2021, please note that all statewide drought emergencies are going to differ into how they how they occur and how they're declared. And some states have different approaches to handling drought conditions across their respective state. From Washington, declaring one on April 8th. This is the 4th straight year of drought declarations. Idaho on April 13th. Nebraska experienced significant wildfires back in March and early April as a result of long-term drought conditions and an exceptionally warm and dry winter. As of July 2nd, an approved federal major disaster declaration due to these wildfires was approved. Then across the state of Oregon, 19 of the 36 counties are under a drought declaration with 2 declarations pending. For many of these declarations across these respective states, they are continuing to cite, again, above normal temperatures, which we'll go into further, below normal precipitation, and that exceptionally low snowpack, that snow drought that we experienced, leading to those exceptional water shortages, because that snowpack plays that role as that natural, non-man-made reservoir that's needed to be able to provide us with the water supplies that we need to get through the summer. Again, that did not develop. As a result, we're going to start to see some of these hydrological conditions stay put, be baked in, and some of the impacts that you'll see as follows. Please go to the next slide. Right, to get to the conditions that we're experiencing across this respective region, it doesn't just take one bad year. Here you can see the SPEI, Standard Precipitation Transpiration Index, over the last 2 years. What you can see here in these dark colors are those areas that have experienced this very much below normal precipitation, as well as that evaporative demand, that high atmospheric thirst that's pulling that moisture out of the landscape, out of the creeks, rivers, and streams, coupled with that, again, lower precipitation, those precipitation deficits, the snow drought that we've experienced. Some of these hydrological extremes that we're seeing across this region are a result of not, again, just one poor year, multiple long-term deficits and long-term drought. Example, again, Washington experiencing its 4th year in a row of some parts of the state experiencing a drought declaration, and Montana being in a drought declaration since 2021. I do want to note our friends here in North Dakota and parts of South Dakota are some of the bright spots across this region, who have not seen some of these mounting precipitation deficits or high evaporative demand, as some of the other places are demonstrated on this map in those deep shades of red. Next slide, please. For this briefing, I wanted to focus in on some of these departures from normal for precipitation. This is starting at the water year, this is starting on January 1. I omitted the water year due to some anomalous events, but starting on January 1 to the present date, Oregon is experiencing some of the largest departures from normal precipitation in the West, specifically in this region, with some areas seeing departures from normal, meaning deficits in precipitation of a foot, if not more. This goes along with southern Idaho and much of Washington experiencing much below normal precipitation, some places in the bottom 10% of record. And a notable trend here is occurring across the Pacific Northwest focused here, is that these are drying conditions since the first of the year that are continuing to compound on top of that low snow drought, impacting available water supply and that increasing demand that we see across the summer months that, again, are placing greater stresses on water supply in this respective region. Next slide, please. Thank you. So going over to the Missouri River Basin now, I really want to focus on that area, that border area between North Dakota, Montana, South Dakota, and Wyoming, Nebraska, and Wyoming as well. Some of these places are seeing precipitation departures of over 6 inches. Mind you, this is not as wet of a landscape, as climatologically wet of a landscape as places like Oregon and Washington. Those 6-inch deficits are a lot and are what is needed to help keep agriculture, the landscape green, and the landscape from having some of these dust storms that occurred across parts of this region in May. Across that borderline, drought conditions do continue to deteriorate, and as well as those impacts are mounting, from curtailments on water supply to water trucking for livestock to poor forage conditions in some of these areas, low soil moisture. Again, looking at North Dakota, parts of northern Montana, these are some areas where there have been, lesser departures from normal, lesser deficits, and conditions are not, drought conditions are not as prevalent in some of those parts of, again, North Dakota and northern Montana. Next slide, please. So looking across the whole entire region here, there is one common thread. This is practically a wall of red that demonstrates across this quadrant of the country sustained abnormal heat, much above normal temperatures across this region in the long term, from January to the present date. These reds indicate departures of normal from 5+ degrees. And this goes back to that snow drought topic we discussed earlier and that evaporative demand, right? These higher temperatures prevented snowpack from developing in a lot of these places. That snowpack is needed to sustain our hydrological conditions and our water supply demands throughout the summer months. Driven by this high heat, that largest non-man-made reservoir did not develop like we usually see it throughout the summer months because it was too warm for precipitation to fall as snow. Those high temperatures continue to increase that evaporative demand as well, keeping that water supply, keeping those stressors on some of the water supply. Some notable exceptions from normal here are looking at southeastern Wyoming, western Nebraska, where temperatures from January 1 to this present date in some places averaged over 7 degrees warmer than normal. And I want to make a note for this region here that we go through the 130-year record that we have. The last 5 years have been the warmest on record for every single Pacific Northwest and Missouri River Basin state since tracking began 130 years ago. These are the places, these are basins, these are states that rely on the development of that snowpack for our water supply. These much above normal temperatures inhibit the ability for some of that snowpack to develop, and therefore, again, placing further stressors on our water supply. Next slide, please. Looking at evaporative demand, again, that thirst of the atmosphere, we can here again see Wyoming, another area where continually high evaporative demand due to these exceptionally warm temperatures has placed a continuous strain on the landscape on drought conditions in that part of this region. But again, the overall trend here is that during a time of the year where we should be actually keeping moisture more locked in, where temperatures should be cooler, we've been seeing this sustained high evaporative demand over the long term for much of this region that again is elevating fire concerns and further straining water resources. Next slide, please. So looking a little bit closer now in the previous 15 days, there is some good news out here, and the little things do begin to add up. Right? There has been some meaningful precipitation in some of these areas that have had prolonged drought conditions to the point where drought conditions have improved. Right? Looking at portions of the central part of Idaho, we're looking at western Montana, again, seeing those sustained either normal conditions in parts of North Dakota. Right? This is meaningful precipitation that took some of these stream flows from setting record lows to achieving near normal conditions. These are, this is a beneficial moisture. However, I do want to make sure to articulate here that the hydrological conditions remain poor for many. The deficits in places like Washington and Idaho and Oregon are still very significant, and it's not going to take just one prolonged rain event to move some of these states out of their drought conditions. But there are some folks that use this precipitation, and it's going to help them dodge a bullet from the worst of conditions that could have developed due to that low snowpack that we've seen and those underlying long-term deficits in our hydrological conditions. Okay, next slide, please. Right, so looking back into the last 15 days, little things matter. These are some short-term drought conditions that have improved. Evaporative demand has been lower than it has been over the last 6 months or year to date. But again, I want to emphasize some of these regions still continually to face deep deficits and will require sustained precipitation to bring long-term hydrological relief. Remember, we need that snow to melt out timely in a fashion to help us sustain our creeks, rivers, and streams and supply our reservoirs. However, this precipitation is beneficial. It does not offset some of those extreme deficits that are occurring across this respective area. Next slide, please. So daily stream flow percentiles. First, let's look at Montana and North Dakota. We can see here the impacts of that recent precipitation and the good that it did in terms of buffering some of these stream flows that, again, previously might have been setting new record lows or had been abnormally low as well. This is beneficial moisture that's going to go into our creeks, rivers, and streams and make a difference in some of these areas that really saw some robust precipitation. However, as we look across this map into these darker shades of red, we can begin to see some of these continually prolonged long-term drought impacts and long-term impacts from the snow drought that we experienced this past winter, these long-term hydrological conditions. Right? We can look at places like the Deschutes Basin that is currently experiencing record low stream flow, the Umatilla River as well. Portions of the Snake River are being impacted. The North Platte, the Belle Fourche, the Okanawan rivers as well are areas to keep an eye on as stream flow conditions continue to deteriorate in some of these areas that are having impactful water supply impacts in these respective areas. Next slide, please. So coming up on my final concluding slides here, we want to take a large look at the major river basins that are experiencing low water supply. The Missouri River Basin June runoff is only 52% of average. The calendar year forecasted runoff for the Missouri River Basin is 60% of average, and already stated reduced navigation flow support in the shortened season are the impacts of this. The reason these flows are low, again, go back to the low snowpack, high evaporative demand, precipitation deficits, and soil moisture deficits as well. In the Columbia River Basin, April to September water supply forecast for the Columbia River at, I'm blanking on the dam off the top of my head, but the most western dam there on the river, forecast of 82% of average. Major tributaries are facing curtailments. Forecast points in the state of Oregon are approaching or near record lows. Many reservoirs across this area are also already drafting or in storage control. These low water supplies are driven by, again, these above normal temperatures, below normal precipitation, and exceptionally low snowpack. Next slide, please. These near-term improvements that I've stated, however, are going to be unfortunately short-lived. If we look across the next 7 days, there's little precipitation forecasted across the region, as well as much above normal temperatures, bringing back that high evaporative demand, that atmospheric thirst, further placing strain on our landscape and the water resources across this region. Next slide, please. So in conclusion, as I mentioned, these near-term improvements are going to be short-lived. These long-term deficits are going to persist, particularly in Oregon, where, again, these deficits are in some places over 12 inches in terms of the precipitation they need to return back to normal. And as a result of these conditions, despite the near-term improvements, drought conditions can be expected to deteriorate further, and impacts will be expected to worsen. These looming high temperatures forecasts will continue to elevate wildfire risk, worsening drought conditions, and place further strain on our water supplies in some of these respective states. Bright spots here, looking at, again, North Dakota, northern Montana, parts of northern South Dakota, that are not experiencing this level of significant hydrological drought conditions. However, looking across the rest of the respective region, again, drought conditions can be expected to deteriorate further and impacts worsen. Next slide, please. So with that, I will hand things on over to Brad Pugh. Thanks, everyone.
All right. Thank you, Jason. Yeah, great lead in there for the forecast coming up during the remainder of July. And then as we look ahead through August and September. Next slide, please. All right, so yeah, Jason just showed the 6 to 10 day temperature outlook, but here's the 8 to 14 day outlook, and this is valid July 15th through the 21st. So the largest above normal temperature probabilities are forecast over the Missouri River Basin. Really starting to see signs we could have a fairly expansive heat wave over the Missouri River Basin, north central plains, kind of beginning this weekend and then continuing for another 5 to 7 days. The week 2 hazards there on the right-hand side shows a high risk of extreme heat over parts of the northern and central plains during the middle part of next week. And there are signs that this heat wave may begin to shift more west into the Pacific Northwest during the later part of July. So we'll watch that. But this obviously has drought implications, impacts coming up. This heat. Next slide. So checking out the week 2 precipitation outlook. Not only are we going to have intense heat there in the north central plains, looking for an increased chance of below normal precipitation as well. So there is growing concern for rapid onset drought during the next 2 to 4 weeks. On our hazards product, we do have a rapid onset drought risk that we release each Thursday. And we may be adding that to the map over southeastern North Dakota, perhaps north central South Dakota, and also down towards like Omaha, down towards the Kansas City area as well. So looking at a couple of areas. Fortunately, northeastern South Dakota picked up as much as 2 to 3 inches of rainfall yesterday, so that should help to minimize their chances of rapid onset drought. But yeah, overall, the next next couple of weeks are going to be pretty rough there in terms of intense heat and high evaporative demand. All right, next slide. Okay, so looking at the 3-month time period as a whole, July, August, September, what to expect in terms of temperatures. During this 3-month time period, we do have a greater than 60% chance of above normal temperatures over the Pacific Northwest. The probabilities decrease farther to the east, but still leaning on the warmer side for the high plains. And then as you go even farther east over the eastern Dakotas, eastern Nebraska, equal chances of below, near, or above normal temperatures. Once again, this is looking over the entire 3-month time period. And the forecast actually tilts a little bit on the cooler side once you move down towards northern Missouri. And as far as precipitation goes, not too much of a signal for the Pacific Northwest, Missouri River Basin, but the forecast does lean on the drier side in northwestern Oregon and western Washington. And next slide, please. All right, so here's the drought outlook, which is valid through the end of September. So we're forecasting broad scale persistence over ongoing drought areas of the Missouri River Basin and the Pacific Northwest, with chances for the drought to expand over parts of the Dakotas and Pacific Northwest. I would say the most likely area to see drought development during the next few months would be the Columbia River Basin in Washington and Oregon, especially if we see those above normal temperatures during the next 3 months. If that occurs, then drought is likely to not only develop but intensify as well. And I believe that's my final slide. So thank you. And let's see, next up is Andy Hoell.
Yeah, that's correct. Thank you so much, Brad. And this is a good lead into what I'm going to present. I'm going to present the forecast strong El Nino in 2026 and 2027 and its potential effects. So let's move on to the next slide. This slide is to show that the ongoing El Nino event is almost certain to persist through early of 2027. This right here is the NOAA CPC official forecast for ENSO probabilities beginning in May, June, and July, and extending all the way to January, February, and March. That's on the horizontal axis. The vertical axis shows the percent chance of certain ENSO conditions: El Nino, neutral, and La Nina. Typically, in most months that this forecast is issued, you'll see bars that are blue and gray and red. Here you only see red, and the reason for that is because El Nino is almost certain to persist into early next year. So on the next slide here, this is where we present the strength and potential strength of this El Nino event. And when we look at El Nino events, we look at them in terms of weak El Ninos, moderate El Ninos, strong El Ninos, and very strong El Ninos. You will not see from our agency Godzilla El Ninos, Super El Ninos, and all El Ninos all the like. It's just in terms of these categories here, very simple. The chart on this slide shows the percent chance of these El Nino categories as a function of time. So the same nomenclature is shown in the prior slide. And as we move through this calendar year into October, November, and December, you can see that by that time, there's a greater than 85% chance of a very strong or strong El Nino event. And we can already see this El Nino materializing into such a strength right now as it's rapidly intensifying. So let's move on to the next slide here. This is a time series of the El Nino Southern Oscillation. This is measured by the Relative Oceanic Nino Index. This index measures the sea surface temperature departures from average in a region called the Nino 3.4 region. That region is over the tropical central and eastern Pacific Ocean. And what makes it relative is it's compared to the rest of the global and tropical oceans. This is a new index that has been implemented by NOAA since earlier this year. What you can see here, dating back to 1950, is the natural oscillations of the El Nino Southern Oscillation, from El Ninos to La Ninas and back and forth. Strong El Nino events are not common, the last of which occurred in 2015 to 2016. You can see that through our time period beginning in 1950, there were just 8 such events. So significant events of note are 1997 to 1998, 1982 to 1983, and 1991 to 1992. So we'll move on to the next slide, please. And what we find here is that the effects of the El Nino Southern Oscillation are global. We live here in the United States, and specifically here we're focusing on the Pacific Northwest and the Missouri River Basin, but this is to note that the effects of El Nino events are global. You can think of it like this. When we have an El Nino event, we are entering a lot of energy into the tropical atmosphere. It's almost akin to dropping stones in water. You see waves emanate from where you drop the stones in. We see that here when we have El Nino events. The only difference here is that we have topography, we have the rotation of the earth, and that there leads to these preferred patterns of precipitation and temperature and other quantities that we care about in the space of drought. So let's move on to the next slide. And in this slide right here, this is a schematic diagram that was put together by colleagues at NOAA. And what it simply shows is how the atmospheric circulation changes related to the El Nino Southern Oscillation. So typically during the winter, where the impacts related to El Nino are most pronounced, we tend to see an extended Pacific jet stream into the subtropical jet stream into California. But unfortunately, what that leads to is in the Pacific Northwest and the Missouri River Basin, warmer and drier conditions than average. So let's move on here to the next slide. On this and several subsequent slides, what we've done here is to take 3-month seasons, in this case, June, July, and August. And what we do is to show the frequency of above and below average precipitation on the left and temperature on the right related to strong El Nino events. So when you see green colors, you see increased chances of above average precipitation. Likewise, for brown colors, increased chances of below average precipitation. And the same applies for the color scheme on the right when it comes to temperature. So for June and July and August, what we tend to see in the upper Missouri River Basin are increased chances of above average precipitation. The same also goes for the Pacific Northwest, but we also note that this time of year in the Pacific Northwest, this is really the dry time of year, so you wouldn't expect to see considerable precipitation during that time. Also related to El Nino events are increased chances of below average temperature. That right here doesn't appear to be materializing, especially in light of the forecasts that Brad had just showed in the past slides. So moving on here to the next slide, this is where we tend to see the really pronounced effects of El Nino events and strong El Nino events, because it coincides with the time of year in which we tend to see the strength of El Nino maximize. This is September, October, November. What we see is in the Pacific Southwest, we tend to see increased chances of above average precipitation, but unfortunately in the Pacific Northwest, we tend to see increased chances of below average precipitation. So that includes coastal Oregon, coastal Washington, the parts of northern Idaho, and also parts of the upper Missouri River Basin. Though that time of year in the upper Missouri River Basin, we're moving into the dry season there. Also related to this is increased chances of above average temperatures in the Pacific Northwest, and notably Washington and Oregon. On to the next slide here. This is for December, January, February. This is a very classic pattern here, and one we've seen very often in terms of precipitation and temperature related to El Nino. We tend to see increased chances of above average precipitation over the southwestern United States. Over the Pacific Northwest, we don't see that strong of a signal this time of year. So this includes Washington and Oregon, and again, this is related to strong El Nino events. But in Montana and those upper reaches of the upper Missouri, we tend to see increased chances of below average precipitation. We see a very, very different pattern in terms of temperature. We see increased chances of above average temperature across the northern tier of the United States, and we see increased chances of below average temperatures in the southern tier of the United States. Next slide, please. This is a cautionary tale. What this slide right here shows is the runoff relative fraction of the 1980 to 2019 average for strong El Nino events, 1982 to 1983, 91 to 92, 97 to 98, and 2015 to 2016. This corresponds here to the water year, October to September. So anytime you see green colors, it means above average runoff for the year, and brown colors indicate the opposite. But the main takeaway from right here is that even during strong El Nino events, there can be very different patterns in terms of runoff. So for every 1982 to 1983 in which the entire Western United States saw above average runoff, you can see in 1991 and 1992 where you get that pattern between the Northwest and the Southwest, in which you see below average runoff in the Northwest and above average runoff in the Southwest. So even though El Nino events and strong El Nino events really tilt the odds to certain outcomes, we can get a lot of variability between those events. And that's something that folks like myself will continue to be watching. So with that, I will finish up, and I believe I'll turn it over to Jim Wallman.
Thank you, Andy. Yep, we will conclude our panels here with finally hearing from Jim Wallman, part of the National Interagency Fire Center, who will provide us an overview of the wildland fireland outlooks. Jim, take it away.
All right, thank you, Jason, Brad, and Andy. Great job leading into this. So if you want to go to the next slide, I'm just going to talk about generally how we make these outlooks. Just like a lot of this is a lead-in, just the current snowpack, drought, fuel loading, which I'll talk a little bit more about that, and then looking at the weather and climate outlooks, which Andy and Brad did so well talking about. We also look at past year's analogs, but with this rapidly developing El Nino, the analogs aren't always quite as strong as what we look at. So that's how we kind of put it together. So you go to the next slide. Just looking at the temperature anomaly, just taking this from NCI and just looking at how warm it was. You already heard about this, but the temperatures really up in the Northwest and the Missouri Basin, while they weren't the warmest on record like they were in the southwestern U.S., they were the second warmest. That had an impact as we go through. You heard about this, the lack of snowpack. So on the next slide, just a review of the precipitation nationwide, or actually, sorry, not nationwide, but just what we've seen the past month. Just continue to be warm and dry in the Southwest and then also the Northwest. And as was mentioned earlier, we did see quite a bit of rainfall and high elevation snow in central Idaho into western Montana. That's helped things somewhat, but that's not going to be a long-term solution to what's going on out west, as Jason alluded to with the runoff. So if we go to the next slide. Just looking at some of the examples of fine fuel loading, I'm showing the Rangelands app here on the left, kind of focusing on a couple of areas. One, the Columbia Basin to the Snake River Plain, and then also into the lower Missouri Basin, specifically into southeast Montana, where we have above normal fine fuel loading. A lot of it in southwest Idaho, it was pretty dry here most of the winter here in Boise, but April was record wet in southwest Idaho. It was the wettest April on record, and what that did is probably occurred at the worst time of year because we weren't growing a whole lot of grass, but then the grass rapidly grew. I took a photo with my dog there in the upper right, just showing how continuous and tall it was while it was still growing in mid-May. She's about 16 inches tall at the shoulder, so you can get an idea. It's pretty tall and kept growing. And then took the other one just below that 3 weeks later, in a similar location, just showing how quickly it cured once it was grown. So we have a lot of grasses that are 18 to 30 inches tall, and much of the Snake River Plain that extends into southeast Oregon as well. And then we're hearing similar reports up in Columbia Basin, where we've already had numerous fires, and then also watching the areas down there in southeast Montana. So the next slide, just kind of going back to the peak winter snowpack. And I wanted to kind of look at this because while, you know, it was just slightly below normal up in Washington and portions of North Idaho and western Montana, that was deceiving because it was all based on the highest elevations. If you look on the right, just coming from area out of Montana, just looking at areas around Flathead Lake, just kind of showing that once you go up about 6,000 feet, the snowpack was really, really weak, indicative of all the areas farther south. And this is taken on April 1st, which is pretty typically near when we see a peak snowpack across most of the West, although in the northern half of the West, like in the northern Rockies, that can occur closer to mid-May, but it didn't change much over the next 2 weeks after this. So if we go to the next slide, just seeing what the impact is on the heavy fuels. So on the left, these are the 100-hour fuels. These are typically your sticks that are about 1 to 3 inches diameter, and you have your 1,000-hour fuels on the right, which are your heavier fuels, about 3 to 8 inches in diameter. You can see the impact overall since the snow came off in a lot of these areas, just for 2 different sites in Northeast Washington or in the Oregon Cascades. Overall, these fuel moisture has been tracking below normal, which is the green line. The record low for that time of year is in the red, and we've been tracking that at times, if not breaking it. Now you can see the impact of that recent precipitation about 15 days ago that has, started to have an impact where it got us up to near the maximum. But the overall trend has been rapid returns to what we've seen. You can see that especially in the 1,000-hour fuels on the right, that while we do see good recoveries, we trend back down to below normal. And likely with the heat building in over the next 2 weeks, we wouldn't be surprised by late in the month, we are back down to setting record lows for the time of year in a lot of these fuel moistures, and that's getting towards our peak fire season. So, it just seems like whenever we get these periods of precipitation, the relief does not last as long as we normally would. When we go to the next slide, just getting that to you, watching the outlook for the rest of this month. We were already starting to see the Columbia Basin really become active already up into the Okanagan Valley. Northwest Washington, we haven't seen any real large fires, but we've already had a lightning fire on the Western Olympic Peninsula, burning at about 3,000 feet. That's about 70 acres. Given the long-term drought that we're seeing there from last year and already the lack of snowpack, while we haven't seen any activity yet, we wouldn't be surprised to see that stand up as we get really warm and dry later in the summer. And then really much of the Pacific Northwest is expected, at least Oregon and Washington, is expected to have above normal safe and fire potential. And then also into the Snake River Plain of Idaho, where we've already had several large fires. There's one ongoing here outside of Boise as we speak, heading up into the mountains here. And then as we get into North Idaho and Montana, that rainfall did a good job, at least for the first half of this month. This is why we have the below normal potential. But now with the heat building in, as Brad was talking about earlier, for the next couple of weeks in the Northwest and then into the Northern Plains and much of the Missouri Basin, we're expecting it to return to more normal conditions across much of Montana. And we will have periods of activity probably as we go into this weekend or early next week. Due to the heat, we will start to have a lot more initial attack, especially if there's any isolated thunderstorms that occur with that. But there's also thunderstorms ongoing right now where we could have some holdovers where the fires, we get the lightning ignitions fires, they burn underground or inside the heavy fuels. We cannot detect them right away. And then when it gets hot and dry, they start to come out, and we call those the holdover fires. So they're not discovered until several days after. Next slide. So looking ahead into August, expecting all the Oregon, Washington, and southern half of Idaho to be above normal potential based on the really dry conditions in the mountains, and then also the fine fuel loading that we have in the lower elevations as well. Idaho and Montana, we think it's going to be a little bit more normal. That rainfall that we got there 2 weeks ago is probably helping to keep us closer to normal. But keep in mind, that is the peak fire season in North Idaho and Montana. It doesn't mean no activity. It means that we're probably going to have a few large fires on the landscape, especially in the Missoula area. We always see fires around there in portions of southeast Montana as well. As we get into the Dakotas, more into the Missouri Basin, we are not expecting anything above normal. Generally, it turns to be kind of green there, but this heat, we're just waiting to see the impacts. That is an area we will be watching for August to see what the heat does with all the fields out there outside of the irrigated areas. Then as we head into September in the next slide, we're going to keep much of Oregon and Washington with above normal potential, and the southern half of Idaho, keeping most of North Idaho into the Dakotas normal for September. Just with El Nino, it tends to be a little bit drier up there as we head into the fall, so we're kind of leaning on that for a little bit longer season there into September. And then finally, on the last slide, on the next slide here for October, we're indicating normal potential, and really right now that's just a low confidence. We don't really have enough of a signal to go above or below normal. Even if we do trend drier into Oregon and Washington, Idaho and Montana, we tend to just the lower sun angle makes it really, really hard to get any real significant fires there. Although it is an area that we will have to watch if, with the strong El Nino forecast, just because we did have an event 2 years ago, we did have quite a bit of fire activity into October in Oregon, Washington, Montana, and Idaho that, while we didn't get any new fires, a lot of the ongoing fires from early in the summer made large runs that summer. So it's just low confidence right now. And that's all I have, and I'll turn it back. Thank you.
Thank you, Jim, for that presentation. We will now have a few minutes for questions. As a reminder, we'll be using Slido. If you're joining from the WebEx desktop app or web app, you can participate by using either the apps or Slido button at the bottom right-hand corner of your WebEx window. Please include your name and affiliation in your respective question. Also, just as a reminder that if we don't get to your question, we will do our best to follow up with you offline and or at the end of today's briefing. We'll also make sure to provide contact information for state-level experts across the region who may also be able to answer your questions as well. With that, please go ahead and find, again, the Slido app, and we will begin our question and answer portion of this briefing. We look forward to taking your questions. I might start us off then with a question here. Andy, I'm going to direct this question towards you. What do you see as the concerns you have in regards to the development of a strong El Nino in the Pacific Northwest, given the long-term antecedent conditions that are present?
Yeah, thank you, Jason. El Nino tends not to lead to conditions that are very good in the Pacific Northwest as it relates to precipitation overall, but of course, snowpack development, which is all important for water resources later in the calendar year. That said, there is a little bit of hope, and we kind of put that in there with the dichotomy between December, January, and February, and September, October, November, where December, January, February precipitation does not lean heavily toward dry or wet related to El Nino, whereas during September, October, November, it leans heavily toward dry conditions. So there is a silver lining. That being said, where we stand right now is really poor water resources, a poor situation that was well illustrated by you, Jason. It was well illustrated by Brad, and of course, Jim in the assessment of wildland fire. So recovery from this drought would probably take several years. And it would be great if we could start immediately for that. Unfortunately, El Nino tends not to lead to that widespread recovery. And as a result of that, I would say there's pessimism along those lines.
Great. Thank you, Andy, for that response. I do not see any questions yet coming through the Q&A chat box, so I will ask another follow-up. Brad Pugh, this one will be for you. Can you provide any context to us on this heat event that is developing over the Western United States here in the near term?
Yeah, sure, Jason. Yeah, we've been watching this really dating back since late last week. Models continue to be very consistent, showing a strong ridge of high pressure developing over the northern Rockies to northern plains, peaking in intensity during the middle part of next week. So, yeah, expecting anomalous heat over the Missouri River Basin during mid to late July. As I mentioned earlier, there are signs that the focus of the heat may begin to shift more towards the Pacific Northwest, though, once we go towards the final week of July.
Great. Thank you, Brad, for that added context. We did have one question come into the chat box, and Andy, I'll direct this towards you. Is it on ENSO? But I'm also happy to follow up with a little more context. Do the effects of past strong and very strong El Nino events vary in the Pacific Northwest?
Yes. The answer to that is yes, and a very resounding yes. I showed one slide with runoff that showed that during the 82-83 El Nino, there was exceptional runoff across the entire Western United States as a result of really consistent and heavy precipitation throughout the wet season. Whereas during 1991 and 1992, it was actually rather different. The Pacific Northwest saw below average precipitation during its principal wet season. And as a result of that, saw low snowpack and low runoff. Those are two pretty strong examples related to that. El Nino as a whole does tilt the odds to below average precipitation, low runoff, but those events can vary quite a bit. So while we do have some pretty confident forecasts, I would say at this time, there does need to be a certain eye toward monitoring our way through this winter to see how everything unfolds.
Thank you, Andy. And I'll provide a little bit greater context here, specifically in the Pacific Northwest. We do see a very, especially as it pertains to precipitation, given the period of record that we have and the amount of strong El Nino events as classified by CPC and very strong El Nino events. We want to make sure that we provide a clear distinction there, that there's a strong El Nino and very strong El Nino events. We do see very significant departures between those two events in terms of precipitation trends, with strong El Ninos favoring towards lower than normal precipitation and very strong El Ninos favoring towards above normal precipitation. As a result, as this El Nino event does develop, we'll be keeping a very close eye on how strong this El Nino event occurs and develops, as that will give us stronger indications in terms of what those precipitation implications might be in specific to the Pacific Northwest. As we look at some of these temperature trends, again, between the strong El Nino as well as a very strong El Nino, there is a clear warming trend with both of those respective El Nino strength events, where strong El Ninos do see above normal temperatures as well as very strong El Ninos in portions of the Pacific Northwest. So thank you very much for that question. I hope it begins to answer it. Please feel free to follow up with another question if more specificity is needed. We do have about a couple more minutes if anybody else has any questions that they would like to add at this time.
Jason, I think there is another question too, regarding strong El Nino events. And the question is whether they differ from one another. And the answer to that is yes. No two El Nino events are the same. And that's been well noted since the 1970s. The 15-16 El Nino, that materialized in a way that had a character that was what we call a little bit more Central Pacific, meaning that its expression was a little bit further toward the Central Pacific Ocean. And as a result of that, its effectiveness in driving above average precipitation in parts of the Western United States was actually somewhat muted compared to, say, the 1997 to 1998 El Nino event, in which that pattern of sea surface temperatures related to that El Nino was exceptional in terms of tilting the odds to above average precipitation across much of the West. Same goes for 1982 and 1983. That El Nino event had a lot of similarities with 97 to 98 in terms of its effectiveness. So all things told, they do differ in their spatial component, but they also differ in their temporal components as well. So 97 and 98, that El Nino event, that was somewhat similar to the El Nino event that we're in right now. It kind of came from a La Nina situation, and that El Nino event intensified at a very rapid pace, similar to the event that we're seeing right now, as opposed to 2015, 2016, which materialized a little bit slower than the one we're seeing now. So they do materialize in different ways. They do have different effects, say, on the Western United States, Missouri River Basin, the Pacific Northwest. And that's what really makes this complicated, forecasting the effects of them, and why we have to continue monitoring as we move through the principal wet seasons in the West.
Thank you for that context. So with that, we'll go ahead and move on. Make sure to thank our panelists for all the great information that they provided. Over the next hour, we'll hear from our drought impacts from across the Western United States from our technical experts providing their perspectives. Drought impacts us all very differently. We will hear about diverse drought impacts from multiple sectors across the region and about experiences of those who are working to respond to these evolving conditions. I'd like to first introduce Caroline Miller. She'll be moderating this next panel. Caroline is the statewide drought lead at the Washington State Department of Ecology. In her role, she coordinates the state's drought declaration process, manages drought relief, and facilitates Washington's Water Supply Availability Committee. She has a background in natural resource planning and environmental conflict resolution. And with that, we'll hand things on over to Caroline.
Great. Thanks, Jason. To start off this session, we will go to Brad Rippey to share with us agricultural impacts across the Pacific Northwest and Missouri River Basin. Brad is an agricultural meteorologist in the U.S. Department of Agriculture's Office of the Chief Economist and the managing editor of the Weekly Weather and Crop Bulletin. He's an author of the Weekly U.S. Drought Monitor and the monthly North American Drought Monitor. Prior to joining USDA in 1998, Rippey worked for the U.S. Department of Commerce for more than 10 years. Since 1994, he has been a columnist and contributing editor for the WeatherWise magazine. Take it away, Brad.
Thank you so much, Caroline and Jason, and to the NIDIS folks for the chance to come on here today and talk a little bit about agriculture, which has been a huge issue over the last several years during this drought across the Missouri Basin and the Northwest. My contact information is here, and move on to the next slide and I'll get started. I just came out of 2 weeks as the lead U.S. Drought Monitor author, so I do have drought on the brain a little bit this week. And I did want to mention that kind of stepping back from this region and looking at the national picture right now, lower 48 states, we still have 48% drought coverage. And if you include abnormal dryness, that takes us up to about 2/3 drought coverage of everything from D0 through D4. So still a very extensive drought footprint, and that is particularly true across the western half of the country. Now, 10 weeks ago, we actually had 15 percentage points higher on that drought coverage. We peaked out at 63%. And the next slide shows the change that we have seen over the last 10 weeks, going back between April 21st and the end of June. You will notice for a lot of the Northwest, especially as you move into Washington and Oregon, it's actually either been steady state or it's actually gotten a little bit worse over the last 10 weeks. We did have that big storm that's already been referenced by earlier speakers across Idaho and Montana that chipped away at that drought there. And we have seen some limited improvement across parts of the middle Missouri Valley as well. But some of the impacts are so deeply entrenched that it is taking a long time to claw our way out of this drought. Next slide. I also wanted to step back a little bit temporally and look back at the interesting pattern we've been dealing with over the last 2 decades. You will notice that at the end of each decade, the 2000s and the 2010s, we actually had very low drought coverage. But during the early to middle part of each of the decades of the 2010s and the 2020s right up to present, we've seen enhanced or expanded or more drought coverage than you would expect to see based on the averages that we have seen long term in drought coverage in the US. So we obviously had a big drought in late 2010 through about the middle part of the 2010s. And then we set back into drought during 2020. And that drought on and off, not continuously everywhere, but has generally continued with that elevated drought coverage right up to present. That has had a big impact on the US livestock industry. We started 2026 with the lowest beef cow inventory in 75 years. And that's a direct consequence of these two big droughts that we've seen. We saw a big reduction, liquidation of cattle inventory during the drought that peaked in 2012. We clawed our way back a little bit by 2019, but then we've been shedding beef cows again since then. There's just not enough forage, there's not enough hay, not enough feed to go around, and it becomes a very expensive proposition to maintain herds. So I'll talk more about that later, but I just wanted to present that picture of how we've been looking at this drought. And it's especially true from the high plains westward over the last couple of decades. Next slide. We produced a product, or we derived a product out of our office. It's now produced and published by the National Drought Mitigation Center, called Ag in Drought. And we look at a number of commodities and crops, and we take the drought monitor and overlay that with the crop or commodity areas each week. And so looking at the crops and commodities we look at, I threw an asterisk beside the crops and commodities that are produced within the region we're talking about today that have greater, or at least 40% or greater, drought coverage at present. And so that would include barley, sorghum, durum wheat, winter wheat, which is being harvested now, and then moving into the forage crops, hay and alfalfa, and then commodities with looking at animals, cattle and sheep. So a big footprint of drought right across some of the things that are produced within the Missouri Basin and the Northwest. Next slide. There's a lot of derivative slides. Again, this is all available. Websites are listed here for both the latest and the archive. And so, for example, hay and drought, the current coverage for the national picture is 40% of the hay production area is in drought. It's actually come down a little bit, as you can see on the right slide, over the last 10 weeks or so, but it's still substantial coverage. The way these maps work is you've got the drought layers, D1 through D4 in the red hatched. Then you've got 75% of the production area or the inventory in the dark green, another 24% in the light green. So you've got 99% of the production covered by the green shading overlaid with the drought. And that is the premise behind the ag and drought maps. Hay is important, obviously, for the livestock industry. And so flipping ahead to the next slide, pasture and range condition, I just want to point out how it has been affected by this long-running drought that has been so dominant in many of these ag production areas from the plains westward. This is national U.S. Pasture and Rangeland Condition Index using weekly numbers provided by USDA NASS, the Agricultural Statistics Service. And you can see, looking at the last 10 years, all of the last 2020 through 2026, are on the bottom of this list, again, showing the impact of the long-term drought on U.S. rangeland and pastures. We're pretty close to the bottom of the barrel this year. 2026 is that red line in the middle. We're not through with the season, obviously, but for this time of year, the only 2 years that we've seen lower rangeland and pasture conditions nationally for early July, 2021 and 2022. So really tough situation for livestock producers providing enough hay and feed for their animals. Next slide. This is a very current look. So July 5th, going back to last Sunday, weekly reported statewide rangeland and pasture conditions. And you will see that statewide rangeland and pastures are greater than 40% very poor to poor in this current snapshot in Oregon, in Wyoming, and Nebraska, kind of at the top of that list for this region. Even some of our more drought-free areas, like North Dakota, almost a quarter of the rangeland and pastures are rated very poor to poor. Even with all that recent rainfall and high elevation snow in Montana, it takes a long time. Once these pastures and rangelands are damaged by drought, recovery is not instantaneous. It takes multiple storms over many months to provide full recovery. So even there, we're still dealing with the impacts of drought, even though it has turned wetter temporarily. Next slide. U.S. winter wheat is another crop that is grown in this region that has been absolutely hammered by drought. And then to add insult to injury, we had some winter and spring freezes that further damaged the crop. You can see in a typical year, winter wheat condition in the spring is usually steady or sometimes even increases. This year, we just kept on a downward spiral as we went through the spring. Again, April freezes really took a hammer to the crop in places like western Nebraska. And we can see over the last 10 years, this is the lowest rated crop in that time period. And in fact, it's really one of the lowest rated crops of all time. The next slide shows the abandonment rate. Now, admittedly, a lot of this abandonment is south of this region as you move into the southern plains. But I think it is worth noting from the national picture that U.S. winter wheat abandonment this year will likely end up around 32%. And besides the outlier there in 2023, which was 33%, also in the middle of another drought that's within the same period here, you have to go all the way back to the Dust Bowl era, 1933, to find a higher U.S. winter wheat abandonment rate. So kind of a dreadful situation for winter wheat producers in the Missouri Basin and elsewhere across the Great Plains. Next slide. The current and final winter wheat condition map of the season shows Nebraska, again, just absolutely hammered. 93% of that crop in the final report of the year rated very poor to poor. Just a terrible situation. And of course, dealing with the drought, the freezes, wildfires earlier this year had an impact on rangelands and a few wheat fields as well. Sort of a middling crop as you move north. South Dakota is kind of split, better in the north, not so good in the south. And also still dealing, again, despite the recent rain, too late for the wheat there. Almost a quarter of the crop rated very poor to poor in Montana, and struggling in Oregon, where a lot of the crop is grown in the northeastern part of the state. Next slide. I'll finish it off with two more agricultural statistics service products, and that is topsoil and subsoil moisture. These data are collected each week during the growing season, and it's a statewide value, and it pertains only to the agricultural regions. And you can see that there has been some recent improvement in Montana and Idaho where that storm hit, short-term relief, but a lot of the rest of the region, North Dakota notwithstanding, really struggling with topsoil moisture shortages still, in spite of some decent spring and early summer rainfall. Numbers near 50% in South Dakota and Nebraska, and even higher, well above 50% in Wyoming, Washington, and Oregon, showing the stubborn nature of this drought despite some spring and early summer precipitation. And then final slide is the subsoil moisture. This is looking below 6 inches. And so in a state like Montana, you can see that, and these are subjective numbers, but they are collected by the same folks every week, year after year. It does show that the longer term impact of the drought, that moisture not really reaching into the lower layers of the soil in areas that recently received rainfall like Montana. So I will stop there and turn it back over to the next speaker and the moderator. Thank you so much.
Great. Thanks, Brad, for sharing that information with us. We will next hear from Craig Chandler, a licensed engineer and water master for Water District 1, Idaho's largest water district. He oversees the administration of Snake River surface water rights, serving approximately 1.5 million acres of irrigated land in eastern Idaho, with annual deliveries of about 7 million acre feet. Craig?
All right, good afternoon. So to give a little bit of geographic perspective, the Water District 1, which I administer water for, covers the Snake River in eastern Idaho. To begin the year, we have to look at carryover from last year, looking at water supplies for irrigation generally. And we carried over a low percentage, a lot lower water last year than we typically do. We carried over 21% of system capacity, where our average is 37%. And that was about 600,000 acre feet below average. That was a result of a hot, dry summer last year and a high draw to storage supplies. So that's where we started out the winter, pretty behind. And then kind of as a recap of, what happened over the winter, In our area, we actually received near average precipitation, but we had record high temperatures. The second warmest temperature over the winter since 1896. So this, of course, led to very, very poor snowpack, especially for those lower elevation areas. The snowpack was particularly bad below 6,500 feet elevation, where it was almost non-existent in some spots. You know, typically that line is around 4,000 feet of elevation. With those warm temperatures, we also saw accelerated snow melt, and that started much earlier than normal. Many stations peaked out in mid-March, and with runoff starting, and that's a month ahead of when it typically does. Many SNOTEL stations were at record low values for April 1st, and that's using a 90-year period of record. The impacts that has had on water right administration have been fairly significant. Because of that early runoff, we had record low water right priority cuts in April and May. So one of the things that we do is we issue a priority that irrigators can use to manage their water supplies and determine what water right priorities they may have. And again, in April and May, we were cutting down to 1891 level priorities, where typically it's rare to drop below 1900. And in some years, we don't even cut reservoir water rights off, which we did this year. So that led to record high storage use to start out the year in that April-May timeframe. And that's records going all the way back to the late 70s when daily administration of water rights began. And then again, the state of Idaho, Governor Little issued a emergency drought declaration on the 16th of April. And with most of southern and eastern Idaho classified as extreme to exceptional drought. One of the other implications of this ongoing drought has been poor storage allocations. So our reservoir system in Water District 1, again, that's eastern Idaho, a little over 4 million acre feet. We had some reservoirs this year some reservoir water right accounts that received very little new fill, particularly Palisades Reservoir, Island Park Reservoir, got about 5% of new fill to their water rights this year. So irrigators already starting off with high storage use, and then paired with, for many of them, low storage allocations. Reach gains is another component that has been affected. What a reach gain is it's a calculation for how much water is entering the system on any given day. And how much water is entering the system, whether it be from snowmelt, tributaries, springs, that's how much can be delivered to water rights. And what we are seeing is we're seeing reach gains that are in the bottom 10th percentile for the last 30 years. So the level of reach gains, we're having to compare against a handful of years over the last 30 years, the lowest that irrigators are having to grapple with. So with the water supply conditions, there are many canal companies and irrigation districts that are operating at reduced deliveries. They all have different mixes of water rights and storage contracts, and they all have different plans for how they reduce. Some of them have, coupled with this by planting different mix of crops or not planting some fields. Many of them are running with reductions ranging from 15% reduction of the water that they typically divert to 33% reduction. Some of them have instead chosen to run full streams now with a plan to shut off early. So with that, we are going to have several canals that will be completely out of water this month. Some of them have, maybe a week left of runtime before they will be off for the year. And we are anticipating widespread curtailment as the irrigation season progresses. So with that, I'll kick it back. Thanks.
Great. Thank you, Craig. Finally, in this session, we will hear from Timothy Klein, ecologist and assistant professor at Montana State University, to take us through some of the local recreational impacts felt due to drought in the region. Tim?
Thanks, Carolyn. I'm excited to share with you all how drought has been impacting our valuable trout fisheries in the West. And also I'll just be demonstrating a new tool that we launched on the 1st of June this year called Troutcast that provides some early warning for drought conditions to anglers and to managers, and also some status and understanding for the public about where our fisheries are in terms of status and abundance, and how they can make smart decisions about where they might go fishing. Next slide. So, yeah. So if you're not familiar, trout fishing in the Western U.S. is a really valuable part of our economy. A new study in Montana suggests that estimated that trout fishing adds $1.4 billion per year to our economy. And that number is likely very similar in surrounding states, Idaho and Wyoming, Colorado, places like that. But most of this value comes from anglers coming from to the state to fish in our fisheries, so non-resident anglers. And a big part of that is the outfitting industry and their ability to find fishing refuge during drought conditions, to move clients around and give them the fishing experience that they want, even when we're experiencing drought conditions and rivers may be experiencing closures. The other part of this is that Montana in particular, and every state manages their fisheries a little differently, but Montana is very proactive in that we have a statewide drought management plan, and we have triggers, different climatic triggers related to stream flow and temperature that may lead to management closures to protect the fishery. So next slide. What Troutcast does, it has two major drought early warning forecasting tools. The first one I'm showing you here is population forecasts. So this is just a snapshot of all of the main stem trout populations in Western Montana and their current status, and where we forecast them to be this year. And you'll see there's a lot of red and orange and yellow, which are stable or decreasing populations. And that just reflects our new understanding of really how valuable water is to trout production and abundance. Most of our rivers are below their long-term average, and many of them have been declining with the historic drought we've seen over the last decade or so. So this is just a snapshot of all the different populations color-coded by their status. If you click on any one of these points, it'll pull up a card. So next slide. And on this card, you can learn about how the population is doing. We have historical and population modeling estimates there on a graph showing how trout abundance has changed through time and where we forecast it to be in the coming year. It also provides probabilistic outcomes for whether the population is likely to grow or increase, decrease, or remain stable relative to last year's abundance or out to 10 years previous in those donut charts. And the final thing here for really long-term drought preparedness is we're able to quantify the value of a cubic foot per second for trout production and abundance. And so the series of charts on the right here is an interactive chart. If you go to the website, you can play around with these, but you can look at how a mean summer stream flow, an average mean summer stream flow affects trout production and abundance, our expectations for how many trout we would have in our rivers under those conditions. Next slide. The other piece of the forecasting tool here provides these management forecasts, which we have two management triggers in Montana. If stream flow drops below the 5th percentile for the historical record on that day, a river will be closed by the state to fishing until stream flow conditions improve. And the other closure we have are Hoell or high temperature restrictions, where if a river exceeds 73 degrees Fahrenheit for more than 3 days, 3 consecutive days, then there will be temporary fishing restrictions that only allow you to fish in the morning when water is cool. So the tool forecasts both of those. Here we're looking at the state or the regional snapshot here for low flow predictions. And you can see that most everything is blue, which actually says we have a very low chance of exceeding those management criteria over the next 1 to 4 weeks. But again, if you click on, next slide. So the low flow restrictions are looking relatively positive right now, but here is the high temperature restrictions. And you can see many of the rivers are getting into the 50 to 75% chance of exceeding a high temperature closure over the next 1 to 4 weeks. If you click on one of the individual rivers, it'll open a card again. So next slide. And this just shows you the probability from 1 to 4 weeks of either exceeding that low flow trigger criteria or those high temperature trigger criteria, as well as associated graphs. So I will say, I think we were anticipating, and we still are anticipating, a very hard summer for trout fishing and for trout populations. But the recent wet weather, which we've heard about a little bit, has kind of staved off what looked like it could be a very, very early set of management closures and criteria. So on those graphs here, we have the historical flow, the hydrograph over time relative to the management trigger. So you can see about 2 weeks ago, we were right on the border of reaching those management triggers, but we had a nice recent wet, cold storm that has bumped stream flows away from that trigger point again. And on the right-hand side, we can see that we were getting very close to those high temperature criteria that would trigger a management closure. And again, the cool and wet weather has pushed us away from that for a little while. But I do anticipate, given some of the forecasts we've seen so far today, that we're looking at what we sort of expected more in July and August in terms of really warm stream temperatures, low stream flows, and potential trout fishing closures. And with that, I will hand it back.
Great. Thank you, Tim. Now we have a few minutes for questions. As a reminder, we're using Slido. If you're joining from the WebEx desktop app or web app, you can participate by using either the Apps or Slido button at the bottom right-hand corner of your WebEx window. Please include your name and affiliation in your question. While folks are thinking of questions, I'm going to pose a question both to Brad and Craig. And this is in the context of how Brad shared that we've seen an increasing number of droughts over recent years compared to the longer normal period. And so I'm curious from the agricultural perspective, if you've seen any lessons learned from droughts a few years ago that informed drought this year, or if you've seen any work to prepare for drought and increase resilience that folks have done because of recent droughts that had an impact this year. Brad, any thoughts first?
Yeah, well, clearly this region is no stranger to drought. Referencing the upper to middle Missouri Valley, really serious droughts in 2017 and 2021, kind of regionalized droughts. And compared to, say, looking back to the Dust Bowl era, there's so much more adaptation and better strategies, everything from cover crops to no-till to preserve moisture. So I think the outcomes in times of serious drought are better than they once were. Even everything from also better irrigation strategies where it's like drip as opposed to just letting water run away. So yes, I think there's obviously still drought impacts and we see profound drought impacts, but the outcomes are far better than what we would have seen, say, 1 or 2 or 3 generations ago.
Great, thank you for that. Craig, anything to add?
Sure. Yeah, so one of the things that we've seen in Idaho is a lot of time and effort going into drought resiliency, you know, both from a physical water supply perspective and from water rights perspective. So for physical water supply, one of the things that there's a lot of attention on right now is increasing storage. So there's a basin study right now going on with the Bureau of Reclamation to look at the upper Snake River Basin in general and to assess, what different options might be available for increasing that physical water supply, whether it be new reservoirs, changes to existing reservoirs to increase capacity, or recharge projects. And recharge projects is a particularly big focus in Idaho, particularly given that groundwater and surface water is administered conjunctively. And so there's been a lot of money put in by the Water Resource Board and from groundwater users and surface water users into developing recharge sites. So, you see a lot of recharge infrastructure being developed, everything from basins that are being dug that can recharge water. There's been some injection wells. And so I would say that's the biggest impact is just on planning to try to conserve the water that is there.
Great. Thank you, Craig. And before we wrap up, I have one question I'm going to pose to Tim. And I'm curious that now, looking at these recent droughts and then looking forward, what are lessons learned you've seen you can take into the future for the recreation, tourism, and fish industry?
Yeah, that's a really interesting question. One of the sort of non-intuitive findings that we came across in this process was that our trout populations tend to persist and just try to survive through droughts. They don't tend to produce a lot of new individuals during those low flow conditions. When they do produce a lot of individuals is in average to wet years. And so there's a lot of discussion about if we can be more strategic with water leasing or other tools in the tool belt to supplement water in years where we have sort of good conditions for producing lots of new trout to rebuild our populations, rather than sort of always trying to compete for a small amount of water when water is most scarce and the trade-offs among different users are most acute.
Great. Thank you for that perspective. And thank you all for those presentations. And now back to you, Jason.
Great. Thank you so much, Caroline. I'd like to make sure to thank everyone who shared their time and expertise with us today, and everyone who worked behind the scenes to make this briefing happen. There's a lot of dynamic impacts and complex conditions across both of these respective regions, and we hope today's briefing shed some light and some clarity on those respective impacts and those regions, across those regions. As a reminder, this recording will be available on the NIDIS YouTube channel and linked from the Briefings event page here on drought.gov. And just another reminder that drought.gov is a great resource for timely and relevant information, and where we will continue to post stories, drought status updates, and regional webinars throughout the remainder of this summer, and as conditions continue to evolve. Next slide, please. As I mentioned, conditions unfolding across these respective regions, they're complex and they're dynamic. NIDIS is grateful to be able to have the opportunity to collaborate with many of these partners that you see here on this screen in this respective relationship where we're always providing each other with useful and beneficial information that can be delivered in order to inform the most timely and best informed decisions that folks here on the ground are able to make. So I want to make sure to be able to put this slide up here into this briefing as a list of additional state contacts for your reference. If you have follow-up questions, please do not hesitate to reach out to any of these respective names that you see here on the screen. They are all instrumental partners in being able to make these briefings possible and to be able to continually to deliver the best information across partners and stakeholders in the Pacific Northwest and the Missouri River Basin. With that, let's go ahead and move to the next and final slide. So this brings us right here up to 2:30. Thank you all for your attendance here today. This will conclude this briefing on behalf of all of us at NIDIS and all of us, all the panelists who joined us here today. Again, thank you very much. And with that, this will conclude today's briefing. Have a wonderful day.